Hi, in this video we're going to talk about how to use triangle trig information here. Remember this that I told you to learn and make sure you understand? Here it is again. We're going to use it to help us solve information about triangles. So let's take a look. In this first triangle, you see it's wanting us to find the measure of each side or the measure of each angle. So in number one here, we have these two sides and this angle. So our goal is to find theta. We need to find how big this angle is. Now, how can we use trig functions to help us? Maybe you know, and if that's fine, I'd encourage you to pause this and skip ahead. Pause it, do it on your own, and then skip ahead. Don't just pause it and skip ahead. Here we go. So the key is to look at this triangle, and we need to connect it back to the trig ratios. So you notice these trig ratios all involve opposite, hypotenuse, adjacent. It's probably going to be helpful to think about that. So if this is my angle, I see opposite would be over here. Where's the hypotenuse? You might have thought 12, but the hypotenuse is actually down here at 13. It's opposite this right angle. And then we have the adjacent side here at 12. Now the trick is to use one of these trig functions and the information we have to create an equation that has one variable in it. Some of you are jumping ahead and saying, hey, we have adjacent hypotenuse. Let's use cosine. You're exactly right. If you're not sure, just think it through. Sine of the angle, we don't know the angle, equals opposite, we don't know the opposite side. So now we have two variables that we know. Tangent, we don't know the angle, we don't know the opposite side. So that leaves us with cosine. So let's set it up. Cosine of the angle equals the adjacent side, which is 12, over the hypotenuse, which is 13. All right, now we need to solve for the angle. How do we solve for the angle? Well, we need to use the inverse cosine of each side to get theta equals the inverse cosine of 12 over 13. Type that ratio into the calculator, and the calculator is going to give you that. And that angle is 22.6 degrees. 22.6 degrees. All right. Encourage you to go ahead and pause it and try the next one on your own. If you see here, it tells us AC equals 12 and asks us to find BC. So we want to find this. Again, we look at the triangle. We have an angle, a side, and another side. It's going to be helpful to focus on this angle and think about what sides I have or am interested in. So 12, how is this 12 related to the 37? Hopefully you said it's opposite. Hopefully you're saying the hypotenuse is here and the adjacent side is here. So if you look at it, we now have, what are we interested in? We're interested in x, we have 37, and we have 12. So we have adjacent and opposite. Do you remember what that is? Hopefully you do. It's right here, tangent. So I can write tangent of my angle. The angle always goes in here. This is always an angle. 37 degrees equals opposite, which is 12, over the adjacent side, which is x. And now we need to solve. Some of you are fine and comfortable with solving this. I would probably recommend taking this over 1 and then cross-multiplying and dividing our answers. So here we take 1 times 12 equals x times the tangent of 37. You can type this in the calculator and get a decimal if you'd rather work with a decimal. I prefer working with tangent 37 myself. I don't have to round then. To get x by itself, I just need to get rid of the tangent 37. So I'm going to divide both sides by tangent of 37. Again, I don't know what this decimal is here, but it doesn't matter. Whatever it is, I'm going to divide here. So in the end, I can just type that all in my calculator. X equals 1 times 12, which is 12, divided by the tangent of 37. And that is going to give us 15.5. 15.92. So we know then that BC is equal to 15.92. All right. We're going to take a look here at solving a right triangle. What does it mean to solve a right triangle? It just means to find all angles and all side lengths. Okay. So here we have two triangles, even though it just looks like there's one. Number 7 is clear over here. See number 7 here. We need to find three things. We need to find the angle B, letter B, letter B. This is important to notice. You'll remember in the Pythagorean Theorem video, we labeled this hypotenuse as C, the legs as A and B. So we've got A, B, and C as my legs. Those are all lowercase. It's important to know that the angle B is opposite side B. Angle A, opposite side A, and angle C is opposite side C, and those are all capital letters. So that is going to play an important role, especially in number 8, where they don't give us the triangle, the picture of it, but they give us enough information. All right, so how do we do this? There's a couple different ways to solve this. I'm going to just take a look at this angle A. What would you do here? Hopefully you're thinking label. Here's the hypotenuse, here's the opposite, here's the adjacent side. That's really going to be helpful because that's going to allow us to set up. I see I have angle, I have the hypotenuse, and I want to know the opposite side here. Let's find A first. Which trig function is going to help us do that? Again, hopefully this is in your head, but you can see we've got an angle, we're interested in the opposite side, and we have the hypotenuse. So that means we're going to use the sine function here. So let's take a look at the sine function. Sine of the angle, 61.7, equals the opposite side is A over the hypotenuse, which is 106.2. To solve this, again, if you want, you can put it over 1 and cross multiply and divide, or in this case you could just multiply both sides by 106.2. Doesn't matter. In the end you'll get A equals 106.2 times, I'm going to run out of room, sine of 61.7. Go ahead and type that in your calculator and you'll find that A equals 93.5. To find B, it's going to be similar, only now working with the adjacent and the hypotenuse. So hopefully you see adjacent and hypotenuse. We're going to work with a different trig function. This time we're going to work with cosine of 61.7 is equal to the adjacent side, B, over the hypotenuse, 106.2. Again, you can cross multiply and divide, or just, in this case, multiply both sides by 106.2. B equals 106.2 times the cosine of 61.7 degrees, which that will give us 50.3. So we're almost finished here. We've got the side lengths. We just need to find angle B. How are we going to find angle B? There's actually a couple ways you could do this. I can think of 4. You could use a trig function, either sine, cosine, or tangent. That would be 3 ways. Or you could look at it and notice, hey, this is a triangle. I have a 90-degree angle, 61.7. These 3 angles have to add up to 180. Let's go ahead and do that. 61.7 plus 90 plus angle B has to be 180 degrees. So I can then solve and find that angle B equals 28.3 degrees. I'm going to do this real quick. I'm going to use tangent. Tangent of the angle B equals, take a look here, tangent of B. You know tangent's opposite over adjacent. So for this one, we have to be a little careful. For this one, The opposite side is going to be 50.3. The adjacent side then is 93.5, which is different from these labels, but these labels were for the 61.7 angle. So I'm going to divide that by 93.5. And then to solve for b, I need to use the inverse tangent. So b ends up equaling the inverse tangent of 50.3 over 93.5. And that should be close to 28.3. I'm going to type it in real quick just to see what we get. We get 28.3 degrees when we round. So, solving a triangle means to find all the angles and all the lengths. Here, we just started one at a time. We found A using the sine. We found B using cosine. We found angle B here by setting up an equation. We know they summed 180 degrees. So we took 180 minus this to get 28.3. Or you could have used your trig functions if you wanted to. Most students find this is easier to do. All right, number 8. Let's take a look at number 8. We've got B is 100, C is 450, and this is a right triangle. Well, I think you have one of these on your homework where you're going to have to draw the triangle. So I'm going to start with my right triangle. That's supposed to be a right triangle. And so remember, C is the hypotenuse. I think you can really do it either way here, but I think it's clockwise A, B, C. This is A, this is B, this is C. I'm questioning that. It's not going to matter too much in the end whether you put A here or B here. I think there is a standard notation. I'm just not sure off the top of my head what it is. So we've got B is 100. We've got C is 450. We now need to solve. We know no angles. We don't know A. Where do you want to start? Go ahead and pause it. Try it on your own. I think you can do it. I'm going to start with finding A. I like the Pythagorean Theorem. I see that the Pythagorean Theorem works pretty good here. So A squared plus 100 squared equals 450 squared. I'm then going to solve. I'm going to do both steps at once. I'm going to subtract 100 squared from both sides. So now this is over on the right side. And I'm going to get rid of the squared and get the square root. And we find that A is equal to a number that I have written on my paper. A is equal to 438.7. Now, how am I going to find angle A? If you look at angle A, a couple ways of doing this. We now know that letter A is 438.7. I'm actually going to use these because there's no decimals involved. If I use angle A, then B and C have certain names, right? C we call the hypotenuse. I'm going to do that in a different color. And B is the adjacent side. So which trig function should I use? For this one, I'm going to use adjacent and hypotenuse. I need to use cosine of angle A equals the adjacent side over the hypotenuse. To find A, we need to solve and use the inverse cosine of this ratio to get the angle. And that gives me angle A. I'm going to type it in. I set my triangle up different on my paper. Of 77.2 degrees. So here angle A is 77.2. How do I find angle B? You could do another trig function, or we can just take 180, so it's 180 degrees in a triangle, subtract 90, subtract 77.2, and that will give me angle B. And that is 12.8 degrees. And so we see that angle B is 12.8 degrees. So, quick review of this problem. I set it up and did Pythagorean Theorem to find A first. Then we looked at angle A, used the adjacent over the hypotenuse, and solved that to get angle A. And then we knew the three angles added to 180, so we did that to find angle B, which is 12.8. An alternative, if you found the angles first, you could then find A using your trig function. I won't go through that here, but I'll just set it up. So if you didn't want to do this first, and you did the others instead, you could have then set up sine of 77.2 equals opposite, which is A, over the hypotenuse, which is 450. I'll let you solve it, but you should get a number that's very close to 438.7. It might be slightly off due to rounding this angle, but that would be an alternative way to solve for that. Now you know how to use trig functions to solve for